Less than 2 years ago, one Chinese model forced the global AI industry to question everything it believed about cost, scale, and technological leadership. DeepSeek showed that frontier-level performance could emerge from outside Silicon Valley's most expensive laboratories. Many investors treated that shock as a rare exception. Moonshot AI has now delivered a second warning, and this one may be much harder to dismiss. The new model is called Kimi K3, and its arrival has reopened the argument that DeepSeek started. Moonshot is presenting K3 as a massive, open-weight, natively multimodal system built for long-horizon coding, deep reasoning, and professional knowledge work. The headline numbers are enormous, but the real story is not simply model size. It is what K3 suggests about how quickly China's AI ecosystem is learning to compete. That is why some observers are already describing the launch as DeepSeek Moment 2.0. The comparison does not mean K3 is identical to DeepSeek, or that every claim has already been independently confirmed. It means another Chinese company has suddenly entered the frontier conversation with a model that challenges comfortable assumptions about who can build advanced AI, how much computing it requires, and how widely it can spread. Moonshot AI is not a household name in the United States, but inside China it has been one of the most closely watched artificial intelligence startups for years. The company became known through Kimi, an assistant designed to handle unusually long documents and complex research tasks. Instead of competing only on conversational personality, Moonshot focused on context length, coding, agents, and the ability to finish demanding digital work. That focus matters because the AI market is changing. The first chatbot boom rewarded systems that could answer questions, summarize articles, and generate fluent text. The next phase is harder. Models must inspect files, write software, manipulate spreadsheets, search huge information sets, use external tools, and continue through complicated tasks without losing the objective halfway through the process. Kimi K3 was built for that next phase. Moonshot says the model contains 2.8 trillion parameters, making it the first open model in the 3 trillion parameter class. It also supports a context window of roughly 1 million tokens and combines text with native visual understanding. On paper, those specifications place K3 in a category that only the largest and best-funded AI laboratories have attempted to reach. But a 2.8 trillion parameter model does not activate every parameter for every request. K3 uses a mixture of experts architecture, commonly known as MoE. The easiest way to understand it is to imagine an enormous organization filled with specialist teams. When a problem arrives, the system does not summon every employee. It routes the request toward a small group of experts whose skills are most relevant to the task. Moonshot's published design indicates that K3 contains hundreds of expert networks while activating only a limited number for each token. This selective routing allows the model to hold an enormous amount of capacity without paying the full computational price on every step. The result can be a system that is extremely large in total knowledge and specialization, yet much more efficient than a dense model of comparable headline size. This distinction is crucial because parameter count can easily mislead viewers. A larger total network may expand capability, but activated parameters, memory movement, communication between chips, and serving efficiency determine how expensive the model is to run. K3 is therefore not important because 2.8 trillion is a dramatic number. It is important because Moonshot is trying to make that number economically and technically usable. The 1 million token context window adds another layer to the story. In theory, K3 can work across enormous code repositories, lengthy financial records, legal files, research archives, or collections of business documents inside a single session. Long context does not automatically guarantee accurate reasoning, but it changes the type of assignments a model can attempt. The goal is no longer answering one prompt, it is maintaining a project. Native multimodality pushes K3 beyond the traditional chatbot format. The model can interpret text and visual information together, examining interfaces, charts, screenshots, documents, and other image-based inputs while reasoning about the task. For developers, that matters because real digital work rarely arrives as clean text. It arrives through dashboards, diagrams, files, browser pages, and software screens. Moonshot is also emphasizing long-horizon coding, where frontier models are judged by whether they can complete whole workflows instead of isolated snippets. A useful coding agent must understand a repository, identify relevant files, create a plan, modify code, run tests, diagnose failures, and revise its approach. Strong performance there is more valuable than generating a convincing answer in a chat window. Early benchmark results have helped create the excitement. K3 has been promoted as highly competitive in front-end programming, spreadsheet manipulation, long context research, and agent-style tasks. Some reported tests place it near or above major American systems in specialized categories. Those results suggest the model is not merely large. It may also be capable in work that businesses are preparing to automate. However, benchmarks should be treated as evidence, not a final verdict. A model can dominate one leaderboard and still struggle with reliability, latency, factual accuracy, tool use, or complex instructions in production. Test sets can favor particular architectures, and company-reported results need replication. The responsible conclusion is not that K3 defeated every rival, but that it earned serious independent evaluation. That alone is enough to make Silicon Valley uncomfortable. For years, the frontier AI narrative centered on a small group of American companies with privileged access to capital, advanced chips, cloud infrastructure, and elite researchers. Each competitive Chinese model weakens the belief that this club will stay closed. K3 suggests frontier capability is spreading across a broader international ecosystem. The timing makes the announcement more powerful. Investors are already questioning whether enormous AI spending will generate returns quickly enough to justify current valuations. Major companies are committing extraordinary sums to data centers, energy contracts, networking equipment, and accelerators. Into that debate comes a Chinese open model arguing that better architecture can produce more intelligence from constrained compute. This is the pressure point DeepSeek exposed. Before DeepSeek, many investors treated the relationship between AI capability and hardware spending as almost mechanical. Smarter models required larger clusters required more accelerators, and more accelerators meant more revenue for dominant chip suppliers. DeepSeek showed that better training methods and model design could alter that equation faster than expected. Kimi K3 does not prove that hardware demand is collapsing. In fact, a model of this scale still requires formidable infrastructure to train and serve. What it does prove is that the competition cannot be measured only by counting GPUs. Algorithms, routing systems, attention mechanisms, data quality, distributed training, memory architecture, and software tooling can narrow performance gaps even when one side has less access to the newest chips. That is why the phrase DeepSeek Moment 2.0 is resonating. The first moment challenged the assumption that frontier reasoning had to be prohibitively expensive. The second challenges the assumption that the first was a lucky accident. When another company reaches the same strategic territory, through a different model and product ecosystem, the market must consider a more unsettling possibility. China's AI progress may be systemic. The word open is central to that possibility. Closed models can be powerful, but their owners control access, pricing, deployment, and modification. Open-weight models give researchers and developers more freedom to inspect, customize, fine-tune, and deploy a system on infrastructure they choose. K3's promised release could turn one company's model into a platform used by universities, startups, governments, and enterprises. This distribution strategy can create impact even when a model is not number one on every benchmark. Developers often select technology based on control, cost, availability, privacy, and adaptation to a narrow domain. A manufacturer may want a model trained around internal engineering language. A bank may require private deployment. A research group may need direct weight access for experiments and evaluation. Open weights also accelerate collective improvement. Once a model becomes available, independent teams can quantize it, compress it, build specialized versions, create serving tools, translate it into more languages, test safety weaknesses, and integrate it into software. The original laboratory no longer carries the full burden of innovation. A global community can turn one release into hundreds of products and research projects. That pattern helped DeepSeek spread so quickly. Its importance did not come only from the launch. It came from the wave of local deployments, optimized variants, enterprise experiments, and technical discussions that followed. Moonshot is attempting a similar network effect with a model built for a broader range of tasks. If the weights perform as advertised, K3 could become infrastructure rather than another application. The strongest opportunity may exist outside the United States. Many companies in Asia, Europe, Latin America, the Middle East, and Africa want capable AI, but do not want permanent dependence on a small number of American providers. An open Chinese model can offer another option, particularly where price, local control, language adaptation, and data sovereignty matter more than having the absolute highest score on a Western benchmark. This is where technological competition becomes geopolitical influence. A model used to build products can shape cloud demand, software standards, education, research, and business workflows. Countries that adopt an AI ecosystem often form long relationships with its tools and suppliers. China does not need every company to abandon American models. It only needs Chinese systems to become credible, affordable, and difficult to exclude. Export restrictions were designed to slow this trajectory by limiting China's access to advanced AI hardware. Those controls still matter, and high-end accelerators remain a strategic American advantage. Yet restrictions also create incentives. Chinese laboratories have focused intensely on efficiency, chip utilization, distributed systems, memory management, model compression, and architectures that extract more value from available compute. K3 appears to reflect that environment. Its selective expert activation reduces unnecessary computation, while Moonshot's research has explored alternatives to full attention. The company has developed Kimi delta attention for long context efficiency and attention residuals to strengthen information flow as models scale. These are not cosmetic changes. They target fundamental bottlenecks in training and inference. Traditional attention becomes extremely expensive as context grows because every token may compare itself with many other tokens. Linear or hybrid attention methods try to reduce that burden while preserving useful long-range relationships. If Moonshot can sustain strong reasoning across 1 million tokens without the full cost of conventional attention, K3 could handle assignments once too slow or expensive for routine business use. Attention residuals addresses another scaling problem. Deep networks use residual connections to carry information across layers, but standard designs can become inefficient or unstable as models grow. Moonshot's research proposes a more adaptive way to combine information from earlier layers. The larger point is that K3 is not simply an expanded old formula. It represents several architectural bets about frontier systems. Those bets now face the hardest test: deployment. Running a model with trillions of total parameters is not simple, even when only a fraction is active at once. The weights require enormous storage, expert routing creates communication overhead, and long contexts consume huge memory. Open does not mean easy. Most people will not download K3 onto a laptop, and many companies will still need specialized cloud providers. This limitation could slow adoption. A smaller model that is slightly less capable but far cheaper may be more useful for millions of ordinary tasks. Developers must examine response speed and concurrency, energy use, failure rates, and maintenance costs. K3 may be a technological milestone without becoming the default model for every organization. Frontier scale creates prestige, but practical economics decides market share. There is also no evidence that American laboratories have stopped advancing. OpenAI, Anthropic, Google, Meta, and other companies continue to develop new architectures, agents, coding systems, and multimodal products. Several closed models may still outperform K3 across broad reasoning, scientific work, reliability, and difficult real-world tasks. The AI race is not a single leaderboard where one launch permanently determines the winner. The more accurate interpretation is that the performance gap appears increasingly fluid. One company may lead coding, another may dominate scientific reasoning, another may offer the best multimodal agent, and another may win on price. K3 adds a powerful new competitor to that fragmented landscape. Its existence forces every major laboratory to improve not only model intelligence, but also cost, openness, context length, and product execution. Independent verification will be essential. Researchers need the promised weights, transparent evaluation settings, and reproducible benchmarks. They must test K3 across adversarial prompts, multilingual reasoning, hallucination, security, tool use, long context retrieval, and sustained agent tasks. The key question is not whether a demo looks impressive. It is whether the model remains dependable after hours of complicated work. Controversy may complicate that evaluation. American officials and industry figures have alleged that Chinese laboratories used outputs from advanced U.S. models for large-scale distillation. Distillation can transfer behavior from one system into another and has become a major intellectual property dispute. Moonshot's achievements deserve serious evaluation, but claims about training data and model access also require evidence and scrutiny. The distinction matters because admiration and skepticism can coexist. K3 may contain genuine architectural innovation while still raising questions about how data, outputs, and computing resources were obtained. The AI industry has long depended on disputed training material, making the argument more complex than a story of one innocent side and one guilty side. Clear standards are still emerging, and enforcement remains uneven. Wall Street will focus on a different question. What happens to AI infrastructure economics? If capable models require fewer active parameters, more efficient attention, and better routing, companies may accomplish more work with the same hardware. That could pressure assumptions about accelerator demand. Yet lower costs could unleash far more AI usage, creating new demand that overwhelms each efficiency gain. This is the classic efficiency paradox. When computing becomes cheaper, society usually consumes more of it rather than less. Faster networks produced more video, not lower bandwidth demand. Cheaper storage produced enormous data collections, not empty servers. If K3 makes advanced agents affordable, millions of businesses may deploy them across coding, design, finance, customer service, research, manufacturing, and administration. For NVIDIA and other hardware companies, the outcome is not automatically negative. More efficient models can reduce the chips required for one task while expanding the total number of tasks worth automating. The real threat would emerge if competitors combine software efficiency with domestic hardware ecosystems that reduce dependence on American suppliers. K3 matters because it strengthens one half of that equation: software. China is developing accelerators, cloud platforms, networking systems, data centers, foundation models, and consumer applications at the same time. No single component yet replaces the strongest parts of the American stack, but each improvement makes the ecosystem more resilient. Huawei, Alibaba, Baidu, Tencent, DeepSeek, Moonshot, and universities pursue different strategies, and that diversity may matter most. An ecosystem can absorb failure. One laboratory may struggle while another finds a better architecture. One chip may be delayed while software teams improve utilization. One commercial model may disappoint while an open model attracts developers. Focusing only on whether K3 beats one American model misses the larger development. China is building multiple paths toward frontier capability instead of one national champion. Moonshot's own trajectory illustrates that change. The company began by attracting users with long context reading, then expanded into coding, agents, multimodal work, and professional productivity. K3 connects those pieces into a broader platform. The model can power Kimi's consumer assistant, Kimi Work, coding tools, APIs, and enterprise deployments. That product layer may determine whether impressive research becomes a durable business. This is the difference between an AI demonstration and an AI moment. A demonstration proves that a laboratory can build something remarkable. A moment changes the behavior of competitors, investors, developers, and policymakers. DeepSeek made technology companies revisit cost assumptions and governments reconsider export strategy. K3 could create a similar reaction if its open release gains rapid adoption and credible real-world use. American AI companies may respond by lowering prices, releasing stronger open models, accelerating agent products, or emphasizing reliability and security. Cloud providers may create optimized K3 hosting to capture demand rather than resist it. Governments may tighten controls, while researchers argue that safety requires collaboration. Every response would confirm the same point. Moonshot has forced the industry to react to China again. The greatest uncertainty is whether K3 can convert attention into sustained trust. Enterprises do not adopt frontier models because of one benchmark. They require predictable costs, stable APIs, legal clarity, privacy controls, support, security testing, and evidence that the provider will remain available. Moonshot must build those foundations while serving global developers who may face political pressure in their own countries. Safety presents another challenge. A capable open-weight model can support research and innovation, but it can also be modified for harmful uses. Long-horizon agents may increase cybersecurity, fraud, automation, and misinformation risks when deployed without safeguards. Closed systems are not inherently safe, yet open distribution reduces the creator's control over downstream behavior. K3 will intensify debate over where openness should stop. Even with those risks, the strategic signal is difficult to ignore. China has produced another model that belongs in the frontier discussion, and it has done so only a short time after DeepSeek transformed the industry's expectations. The most important conclusion is not that China has already won the AI race. It is that the race can no longer be described as Silicon Valley competing against a distant follower. The next stage will be decided by execution. Researchers will test the weights, developers will measure real costs, businesses will compare agents, and governments will examine security and intellectual property concerns. Some claims may hold up, while others may prove less dramatic outside controlled evaluations. But even a partly successful K3 would show that frontier competition is becoming broader, faster, and less predictable. That is why Kimi K3 feels like DeepSeek Moment 2.0. The first shock revealed that the AI cost curve could move unexpectedly. The second suggests China may possess a pipeline capable of repeated surprises. If Moonshot turns K3 into a global developer platform, the impact will extend beyond one model. It could reshape pricing, open source strategy, hardware planning, and the balance of influence in artificial intelligence. One launch will not settle the future of AI, but it can change the questions everyone asks. After K3, investors must evaluate software efficiency alongside chip demand. Developers must compare control and openness alongside benchmark scores. Policymakers must consider whether restrictions slow competitors or motivate alternative designs. Silicon Valley must prepare for a world where the next frontier model may arrive from anywhere. The DeepSeek moment was never important because one model briefly dominated the news. It was important because it shattered certainty. Kimi K3 has now struck the same vulnerable point, only with greater scale, longer context, multimodal capability, and an open-weight strategy designed for global distribution. The message is simple. China's AI momentum was not a one-time event, and the next surprise may already be under development. If K3 succeeds, the winners may not be limited to Moonshot or China. Developers could gain more choices, enterprises could receive lower prices, and researchers could access capabilities once locked inside private laboratories. Competition can accelerate progress, but it also increases geopolitical tension and safety pressure. The challenge is ensuring that faster innovation produces useful intelligence rather than a race without shared rules. For now, Kimi K3 has accomplished something every technology company wants. It has forced the world to pay attention. Whether it becomes the leading open model or an ambitious experiment will be decided by independent testing, real deployment, and developer adoption. But the comfortable era of assuming that frontier AI belongs to a few American laboratories is ending. DeepSeek opened the door. Moonshot has pushed it wider. If you enjoyed this breakdown, subscribe and turn on notifications for our next report on China's most important technology breakthroughs, the global semiconductor race, and the companies reshaping artificial intelligence. The next major shift may not arrive with a warning. And as Kimi K3 has just demonstrated, the distance between an unexpected announcement and a global market reaction is becoming shorter every year.